think that the one message I can leave behind is to say that the universe is one large cosmic enterprise, and we're all on some kind of a journey, and I'm not sure where we're going, but it's been pretty interesting. And let's hope that our species will live long enough to be able to enjoy where this journey is taking us. I hope that we are responsible enough that we will try to save our species from extinction. We should also save all the other species on our planet from extinction.
Welcome to the Journey of the Universe 10 Years Later podcast. My name is Sam King, and today we're fortunate to be joined by Dr. Karim Ahmed. Dr. Ahmed is an internationally recognized science and policy expert in the field of environmental sciences, natural resource management, technology assessment, and public health. One of his chief areas of interest is the impact of climate change and global warming on human health and natural ecosystems, and in assessing mitigation and adaptation approaches to address them. His specialty area is related to the human health impacts of air and waterborne pollutants and chemical agents on adults and children, and in the risk assessment, risk management of chemical substances, agricultural pesticides, and consumer products. His interest in basic science research spans a wide range of subjects, including physical biochemistry, origin of life studies, theoretical biology, systems analysis, and mathematical physics. Dr. Ahmed, thanks so much for being with us today.
Thank you for inviting me. It's quite an honor to be participating in the 10th year anniversary of the Journey of the Universe, which is a wonderful documentary about our cosmic journey. And I'm very happy to be participating in this endeavor.
Absolutely. And I'm really grateful to be connected with you through Professors Mary Evelyn Tucker and John Grimm, and really inspired by the work you're doing, Dr. Ahmed. And I'd like to start by hearing a little bit more about your origin story. How did you come to pursue your work in climate change and public health?
Well, maybe I should start from the beginning. That might give you some idea of I've had a variegated history in terms of my interest, my orientation in life, so to speak. So to go back to 1939, which when I was born in Kobe, Japan. My mother was Japanese, my father was from India. And so after that, I lived in Shanghai, China, for about 4 years during World War II under Japanese occupation. So what I saw early in my life was a lot of, how should I say, hostilities, violence. We were bombed during the liberation of China towards the end. And then after that, we moved back to India. My father was from Mumbai. We lived there for a couple of years before partition happened. And then I saw more violence and disturbances. So my life was full of, you might say, a very non-normal life, you might say. And then we moved right after that to Pakistan after partition. So I grew up there, and then I came to the United States to study. But during my formative years, while living in Pakistan, and I went to college there, I began to ask myself this question, what is life all about? And I went to study sciences, the natural sciences. So my undergraduate degree was in both physics and chemistry. And I was not exactly sure where I wanted to be, even in the sciences. But during those teenage years of mine, I also discovered another side to my nature, and that had to do with the spiritual side of my nature, which meant that I became a very devout Muslim. I grew up in an Islamic culture. And I used to go to prayers in the mosque 5 times a day, kept all the fasts during the month of Ramadan. I knew how to read Arabic, and so I could read the Quran. But I was at the same time studying physics and chemistry and wondering which part of my nature was really ascendant. So one day I remember sitting in my class in physics. I stood up and to ask a question of the professor. And I said to him, started my question by saying, why? And he immediately stopped me mid-sentences. In sciences, we don't ask question why, we only ask how. We try to understand nature, we don't try to ask why nature is there or why there's meaning to what we study. So I felt quite abashed by that. To me, that seemed like a very, and I was a good student. So it was not something that I felt as if I had broken some chain of reasoning there. But that question lingered with me all my life. And later on, when I did research, more in graduate school, when I came to the United States, the question of why never left me. It was always there. Not because I was asking that question of why in the context of physical sciences or biological sciences, but more in terms of a metaphysical question, sort of like between, you say, science and religion in some ways. So that became a question that I'm still asking that question. Why do we have something rather than nothing? Why do we have life instead of non-life? Why is the universe, mostly lifeless or seemingly lifeless? And so those questions have never gone away. They're still there. But on the other hand, when I started working in the 1960s in my graduate program, I became aware of many social issues of the day. There was a Vietnam War, which I got very much involved in, the anti-war movement. There was the civil rights movement. I got very much involved in the civil rights movement, working as a volunteer in low-income neighborhoods. Did my first environmental project looking at lead poisoning, childhood lead poisoning in a neighborhood, and got a research project done out of it, which ended up with city ordinances that required landlords to remove leaded paint from their premises, and so on. And when I finally got my PhD in physical biochemistry, and I did my postdoc work, and I was going to pursue a traditional academic career, something tugged me. I think it's not only happened to me, but many of us, my colleagues, who were both in pursuing scientific careers and in the legal profession. Some of my early colleagues at NRDC were lawyers who had graduated from top schools in this country. We all were very much taken up by what was happening in the 60s. So many of us abandoned our traditional path and went into public interest work. And so, a long story short, I got involved in the early days of when we got concerned about stratospheric ozone, how CFCs were destroying the ozone layer. I got very much involved with that issue with Professor Sherry Rowland and Maria Molina, who discovered this. And out of that effort, we eventually got the Montreal Treaty. So that was how I began my career working on atmospheric issues. And while this was going on, we became aware of climate change back in the late 70s, early 80s. So again, to make a long story short, that's how I got involved ultimately in the question of climate change and global warming. That I hope can answer your question. But I had to go back to my roots to tell you that I lived in a very, you might say, world that was not normal in the sense that most people think about the world growing up. And I knew from the beginning, and I also noticed that the incredible problems of refugee problems in Pakistan after partition. We moved there. We lived comfortably, but people around us were living in refugee camps everywhere, in tenements, and life was miserable for most people. And I always wondered about why is it that some of us live so well and so many people live so poorly? And that affected me tremendously.
Absolutely. I'm really moved by the depth, the texture of your life journey and how you're bringing your scientific training to bear on these social and ecological crises that you've experienced throughout your life. And I'm curious to hear how you have understood science in the context of deep time and a larger universe story, and how that has influenced your life and work.
Yes, I think that's a very good question. Deep time. Yeah, we go back, what, 14.5 billion years ago. At least that's what we believe, using the Hubble constant. Think the universe was created then. And most people think that 14.5 billion years ago was a long time ago. I don't look at it that way. I think it's very, very recent. And anyone who thinks that that's where everything began cosmically may have to rethink their thinking, particularly with the discovery of dark matter and dark energy, which we have no idea about right now. So there's something more mysterious in the universe than just the universe story that we so far know. You know, back in the 30s, when we first discovered that our Milky Way was not the only galaxy in the universe, to find that there were other galaxies that were moving away from us. When Hubble discovered that, that was quite incredible. We suddenly realized that our universe was much larger than it was. And now we think that the entire universe that we see around us is the only universe there is. Well, we don't really know what's beyond our current universe, but I'm not going to speculate on this discussion today. But we have to keep in mind that deep time is deeper than we have so far defined it. The second question that we should ask is, what is the connection between the physical world and the biological world? Is it something completely different, or is it a seamless whole? And I've always asked this question, and I have developed my own thoughts on this about the seamlessness of the journey of the universe. It's not just one thing here and one thing there. It's one large cosmic journey.
You write in one of your essays that, quote, life has never been a singular journey, but was and always is a collective enterprise from its very beginning, unquote. So you talk about this connection between the biotic and the abiotic worlds, this connection between biology and what could be considered inanimate matter. Could you speak a little bit more about your perspective on the sort of interdependence of life from its very origins?
Yeah, you know, the kind of irony. I started studying the question of how life originated from the beginning, you know, going back to the primordial soup, so to speak, 4.5 billion years ago on the surface of the earth. And at that time, I was basically asking the why question. Why did life originate in the first place? But then I soon realized that that's not the right question to ask. Is the how question becomes more important. How did life come out of so much inanimate matter? So you see, I reversed my interest from the why to the how. And what most people in evolutionary biology do not understand, and they don't take into account, is that life, the condition for life at that primordial period was extremely nasty. With volcanic eruptions, meteor bombardment on the surface of the earth, it was not a very friendly environment for life to have originated. That you have to keep in mind. And those of us who work in this field understand that. So can you imagine one little organism just coming out of nowhere, suddenly out of random, and then suddenly surviving, and then proliferating, and then somehow the other evolving into the next species and so forth? That's the current thinking. At least when evolutionary biologists think about evolution, they think in very simple terms, that there were a simple organism like some bacteria sitting on the surface of Mars, let's say, still sitting there. You know, when they talk about extraterrestrial aliens, they think about some simple unicellular organism somewhere. Well, it turns out that if life originated like that, it would have been snuffed out almost immediately. The conditions were extremely hostile to life. So the only way life could have originated, and if you really think about it deeply, it has to be some kind of a collective. You have to have lots of organisms evolving about the same time, each helping out. And that's what I call the ecosystem model of life's origin. It's not only my idea of, which is a radically different way of looking at evolutionary biology, but also I think that most people working in the origin of life studies would probably accept this idea. But then later on, as evolution occurred, it also occurred in an ecosystem manner. Life is always a collective. It takes a village to keep life going. It cannot be done by singular cell. Now, the current neo-Darwinian paradigm, the so-called selfish gene model that most biologists accept, they think that each gene is pretty much on its own, and that it's competing with other genes to survive. And they don't look at the interdependence of different organisms that have to live together in an ecosystem. So then the selfish gene model, which is finally getting, you might say, modified, but it's taken a long time for biologists to think differently. They think that life is much more simple than it is, that it all happens by small little steps, by the conventional idea of genetic mutation. That's not the way life originated, nor is it how it's evolving today.
I know you write, among other topics, about horizontal gene transfer and the way that is one phenomenon that sort of challenges the primacy of natural selection as like the sole driver of evolution, and how it speeds up the evolutionary process to create an interdependent collective of organisms in larger and larger biomes. I'm curious to hear you speak a little bit to what is horizontal gene transfer teaching us about the evolutionary process.
Yeah, horizontal gene transfer was something that was really discovered 20, 30 years ago. And it's a relatively new idea. And most evolutionary biologists, particularly those who work at the organism level, have not really paid attention very much to it. But here's the thing. Ask yourself this question. You are an organism that's trying to survive in a hostile environment when life first originated on Earth. How are you going to sit around and wait for the vertical form of genetic mutation to make you fit into the new environment that you're living in? Not possible. That's just a question of common sense. So when they discovered horizontal gene transfer back in the late 1990s, 1980s, they discovered that bacteria, unicellular organisms, in fact, were able to evolve very speedily because they took big chunks of DNA and exchanged within themselves, either through a plasmid or through other forms of conjugation systems. And that is how, in the evolutionary model that you want to build, you begin to realize that by horizontal gene transfer, you can get enormous number of new organisms that would come. You're mixing and matching genes, you see, randomly. There's no selection going on here except phenotypically. Now, if this organism were able to survive the hostile environment, it would be chosen. So it doesn't go against the concept of natural selection at all. It's completely compatible with natural selection. But all you're doing is you're increasing the possibility that new organism that could survive in this hostile environment would be selected. Otherwise, it would be too slow. If you go for base pair changes or base pair substitution, it would not have been able to do so. So horizontal gene transfer was there from the very beginning. And we only discovered this very recently. And what then happened, and I just want to jump right to it, is that once the unicellular organisms became into multicellular organisms, and then animals and plants came out of it, you couldn't easily have horizontal gene transfer occur between different cells, between different organisms. It was very difficult because with unicellular organisms, you can have side-by-side exchange. So came viruses. Viruses are horizontal gene transfer agents for higher organisms. And viruses, people have always wondered, what the heck is viruses doing here? Why are they so pathogenic? Why are they causing pandemic? Well, 99% of viruses are perfectly harmless, but there are horizontal gene transfer agents for higher organisms. And we're only beginning to discover that. We're beginning to understand the real role of viruses today. Only a few people in evolutionary biology have understood this, but it's slowly sinking in. And in the writings I have done recently, but I've not published most of this work, I place a very important place for viruses in biological evolution.
Clearly, over the last few years, we're seeing the, how powerful the viruses we coexist with can be. So I'm really fascinated to hear your comments on horizontal gene transfer and viruses, in the early evolutionary process. You also write about the phenomenon of epigenetics, and I'm curious to hear how epigenetics works and how environmental factors can influence the transmission of genetic expressions between generations of life forms.
Yeah. So one of the first things I think you learn when you study biological evolution in college is that natural selection does not happen at the gene level. It's not a genotype that's selected, it's the phenotype that's selected. So it's what is manifested by the gene that either fits into the environment or doesn't fit into the environment. That's how natural selection works, okay? That's very classical. It goes back to Darwin. Darwin was the first. So when we call something neo-Darwinian, we mean exactly that it is the phenotype that selects environment or that we fit into that environment. There was another theory at one time before Darwin came along, was done by Lamarck. And Lamarck believed that we were able to acquire certain characteristics from the environment that would shape and would be inherited by organisms. But that, of course, went away once we discovered genetics in the early part of the 19th century, and then we developed the model that everything occurs at the genetic level, and the concept of acquired characteristics could not be inherited. But what we're discovering with epigenetic mechanism is that we have a new way of looking at the question of acquired traits. And some people call it neo-Lamarckian. So this is how it works. Ask yourself this one simple question. We have the same gene in all our cells of our body, whether it's in your brain cell or liver cell or in your bone cell, what have you. Yet they all express differently. So how do we get this kind of cellular differentiation in our? And when I was in graduate school years ago, they said, my professors used to tell us that the biggest question, unanswered question in biology was cellular differentiation. How the different cells in the body express differently. Only recently, again, going back to the same time as horizontal gene transfer, we discovered epigenetics, meaning we discovered that the reason why different cells express differently, both in terms of this fetal stage and later on as a child, development occurs in a child and then as an adult. We have different triggering points, hormonal secretion, signaling between cells and all, that allows certain genes to express themselves and other genes to be silenced. Out of that understanding, we have then understood, if you understand cellular differentiation, you understand epigenetics. So now we realize that certain types of chemical agents, let's say DDT or PCBs or something like that, they trigger off certain reactions in the cell that might, for example, methylate a cytosine base pair, which is one way of doing it, or modify the histone molecule around which DNA is wound around. It will either silence or evoke expression of that particular gene. And that's what epigenetics is. And it's nothing new, but it's something we just rediscovered by understanding how different cells express differently, the different properties in the body. And now we're discovering that many of the epigenetic, might say, when epigenetics changes the germ cell line, that particular germ cell line can then be inherited through many different generations. Experiments have now been able to prove that. So here we have a sort of a neo-Lamarckian concept of biological evolution, but it's not either or, it's both. We have both the Darwinian model and the Lamarckian models sitting side by side. And horizontal gene transfer and virus as a vector for horizontal gene transfer does not in any way change the our current biological outlook, but it does change the way we understand life and how life evolved.
Yeah, you also describe life from your essays as a nested concentric series of natural ecosystems. And I was struck by this idea of concentric circles. Sometimes you see in the Confucian tradition of the human as part of a larger family and society and biosphere and cosmos, having these larger scales of identity. I'm curious to hear you speak a little bit more, reflecting on epigenetics and the influence of environmental factors on potential gene expression. Like what do you mean by that image of nested concentric series?
So if you think about our globe, our planet Earth, as one large biosphere, you can start at that level. And that you think about all the different biomes that exist within that biosphere, that becomes the next level. And then between, you can think about each of the genus and species that exist in each of those biomes, and that they all are interdependent and they need each other. You have producer organisms, you have consumer organisms, you've got a hierarchy, you've got a food web, without which no life system could. Biologists realize that once we have an enormous loss of biodiversity today, all life on the earth will just vanish. You cannot sustain life without having a very rich ecosystem. A forest cannot exist if the ecosystem is destroyed. When you try to do reforestation of a forest, you have to bring all the flora and fauna back. You can't just plant a few trees. That doesn't work. So if you go back and think about it that way, the ecosystem, the large biosphere itself is a collection of different biomes and ecosystems. So if you break it down from that perspective, and you want to answer your question about religion and culture, you can think about the biosphere and human culture would be two different parts of that concentric cycle. And then it would break down into different religion. In the same sense, you've got a global ecosystem, you've got a biome, and you've got genus and species. So the world's religion could be considered to be, let's say, a genus. The Abrahamic faith could be a genus, out of which Islam, Judaism, and Christianity came out. And you could go backwards and say, but they're all part of a culture. And the culture, either Eastern culture or Western culture. So you see, you have another concentric circle to look at. And then from that, you can look at the globe as a whole. So the biological concentric cycle and the human concentric cycle have something in parallel there. And in a sense, we're all part of one large whole. But then we are part of that large whole, but we are all connected to each other. Where, when you say Buddhism is different from Islam, or Hinduism is different from, say, Christianity, but they also have lots in common. For example, if you look at the teachings of Hinduism, and you look at the philosophical side of Hinduism, you see the same concept of monotheism arises out of polytheistic practices in the common man. On the other hand, you think about Christianity, which is a monotheistic religion. Yet when you go back in medieval days, all the different saints were there, and you had different kinds of orders of Christianity, which you might say, in a sense, saint worship was a form of polytheism of sorts. So you see, there is that kind of interconnection between different types of cultural norms, and in the same way that it mimics about the biological biomes we've just been talking about.
I think it's really interesting to approach religions from an ecological and evolutionary perspective. And I'm curious, you also write that life itself is a non-deterministic and emergent phenomena that's not easily reducible to a few of its component parts. And I'm curious to hear you reflect more on that idea of emergence in the evolutionary process.
Emergence comes out of the kind of the Whiteheadian concept of process evolution, meaning that there is no one goal. That you can think about it two different ways. You can think about the Whiteheadian view that there is some kind of a teleological end that we are all moving towards. Or you can think about the whitehead idea of things moving and creating its own domain as it moves along the evolutionary pathway. And I happen to be a little bit closer to the Whiteheadian view, but I also respect people who think the other way, that there may be some teleological end we're moving towards. It's not that it's not a question of either or, it could be a little bit of both. But I happen to favor the fact that life itself has not found its end journey yet. It's moving to an end that we don't know where we are. I mean, the universe is full of mystery. And one of the mysteries of world that we live in is the fact we have no idea where we are all headed to. Some days I feel so despairing about the way we're treating our planet today. I feel that human species itself will go extinct, or that we don't deserve to survive on our planet because we're such destroyers of our planet. So there are times when you think like that, then you know that there is no higher destiny for you. On the other hand, if you believe in a destiny, then you can be a bit more optimistic that human beings will somehow or the other conquer its mistakes and somehow or the other come out of this hole and intact, that we will become a more enlightened species. I just don't know where we're headed. We could go either way.
Absolutely, and we're at this critical threshold, as you know, and have written extensively about. I certainly hope that we are moving toward what Thomas Berry called this ecozoic era of human Earth flourishing and sort of transforming our social and cultural institutions to be more in harmony with life's biological systems.
And by the way, I really like what Thomas Berry said there. I wish he's right on this, that we are moving into a more enlightened world. And some days I feel that way. Other days I don't. So I vacillate between the two points of view that there is probably. And I know, as I said, the Whiteheadian view is what Thomas Berry follows. And probably he's right that we will muddle through this somehow. But as a scientist and as a person who works in climate change on a daily basis, I sometimes despair.
Yeah, and I think a healthy balance of despair and hope is really important. And I wanted to, one of the things Barry writes about, and I know you've also written about in your work, is the emergence of aesthetic beauty and what we find beautiful in connection to the planet's biosphere. And you suggest that co-evolutionary fitness of life forms is closely related to aesthetic beauty. In other words, that recognition of beauty in natural life forms is an evolutionary means to keep the biosphere viable in its most optimal state. I'm curious to hear you reflect more on that.
I'm not sure I can do much justice to this short answer I'm going to give you, but think about it this way. Life is not supposed to just think, you can't think about life mainly as a fit versus a non-fit. You have to think about life system as being optimal. It means things are working both from a point of view of material and energy in an optimal sense. So if you think about it that way, then you ask yourself the question, what is the most optimal thing for, let's say, a plant, Texas, a leaf going around its stalk to get the maximum amount of sunlight. And you discover that it's a Fibonacci sequence, for example. So the Fibonacci sequence is how we have discovered, the botanists have discovered, is how the leaf maximizes its ability to get the most amount of sunlight. And then you discover that Fibonacci series itself is related to the golden mean. And then you discover that the golden mean has aesthetic beauty to it because so much of our architecture and our human body proportion all have a Fibonacci sequence and golden proportion there. So then you ask the next question is, if that's all true, then there is something to do with our perception of beauty and optimal systems. They go together somehow. Same thing with fractal art. You can think about that as being some kind of an optimal way. Mathematically, things fall into that particular kind of pattern. And so, and then also when you think about things like pollination and the fragrances that are given out by flowers and the color and tone of our surroundings, how much we can co-evolve, that human beings grow a lot of pollinating flowers in our gardens, and the bees are attracted to it. So we can co-evolve with bees. So, one thing after the other, we can just keep on multiplying these ideas. But the questions, we still beg the question of what do we really mean by beauty? Okay, I'm not going to try to answer that question now, but even whether it's culturally determined or whether it's something more inherent in mathematical proportion and so forth, I don't have a ready answer to that. I have explored all those questions and I don't have a ready answer, but I can tell you that beauty and optimal systems of evolution go together somehow. And that's how we've co-evolved in this universe, in this biological universe of ours. Otherwise, I don't think we would be able to understand the concept of beauty in the first place.
I think beauty is such a powerful phenomenon, and it's interesting to hear you write about its relation to biological patterns. And I certainly hope that beauty can be a way of galvanizing environmental protection around the globe. Speaking of beauty and seeing our cosmic home anew, we're getting all these amazing images from the James Webb Space Telescope. And in a recent episode, I spoke with Dr. Sardmeet Kanwal about Webb's image of Deep Field, released in July. And I'm curious to hear your reflections.
I'm going to give you an answer you might not necessarily like, but I'm not terribly impressed by our ability to see the universe in such sharp focus. Not because I actually enjoy seeing all those pictures on the Webb telescope. Don't misunderstand me. And the fact that we can go back and see, those events nearly beginning of what we call the beginning of the universe of ours, and we can now begin to see some exoplanets maybe more sharply by using the Webb telescope, because it's using infrared above the Earth's atmosphere and can see things that we could not ordinarily see. But infrared electromagnetic radiation is the same as light radiation in terms of the speed with which it arrives on our planet, 300,000 miles per second, very slow. We simply do not know what's going on, even at the nearest galaxy, like Andromeda, in real time. It takes us billions of years before we find out what's actually going on there. So we live in this claustrophobic universe of our own making. I wouldn't say our own making because we don't have any other probes besides light. We can't use sound because sound moves, first of all, very slowly, and it's only where air molecules are available. So we can't go and hear what's going on the surface of the sun. So we need a new medium by which we can capture the rest of the universe in real time. And the thing that we will discover, if we did have that kind of technology, and we may not get that technology for another few centuries, because we don't know much about dark matter, dark energy, and so forth, we will discover life everywhere in the universe. That's something we have not been able to. We can speculate about exoplanets and so forth, but we can't communicate with anything. We can't, what's the point of communicating with another life form 2 billion years later? When we see a galaxy up in the, in the sky, it's several billion years later that we're seeing it, not what's happening there right now. Until we discover that kind of technology, none of this really matters. So, it's a little feather on our cap to put together the Webb telescope, but I'm not terribly impressed by it. So I have a different take on it. We need a new physics and we need a new biology to get us there. We need to figure out a way for us to tap that kind of signal. And I have written some things about it, and I've not published it yet because I know it would not be received well by people in the theoretical physics community. But I have some ideas on this. But my motivation is because I want to communicate more effectively with other life beings around the universe to see what they have done right, what they have done wrong. Are we moving in the right direction? If there is more life elsewhere, then I will have to revise my view that human species may not go completely extinct. We need to learn lessons from other civilizations. Right now, we don't have that. So I feel like I'm in a prison of our own making because we only have light telescopes to look at it. Whether it's X-ray, infrared, ultraviolet, doesn't matter. It's all electromagnetic in origin. Very, very few tools at our. So that's my message to you, to say that the universe is much more beautiful and much more wonderful than we have so far taken. It's not just all nothing out there, a physical universe, lifeless forms. I think the universe is teeming with life. It has to, because for people who work in the origin of life field, we recognize that most of the amino acids and nucleotide bases didn't come from Earth. It came from interstellar space, where there's a lot of organic chemistry going on, and was brought to the Earth by meteors. It's happening all over the universe. All the exoplanets are getting, at some point or other, got the same amino acids and nucleotide bases. And once you've got those, and you've got lipid, and you've got carbohydrates, life will occur everywhere. We need to get in touch with them.
Such a fascinating insight about almost playing catch up through James Webb about what's happened billions of years ago by tracing light. And if only we had those instruments to be able to contact or somehow detect life elsewhere in the universe. But
one thing good about the Webb telescope, we can actually see what happened then. It's like seeing an old video of something that happened a long time ago. So that if you have an instantaneous communication with something that happened a long time ago, you couldn't tell what happened then. So in some ways, having a light telescope is good because it tells us historical past. But we also need to know what's happening there now. Those galaxies are already gone. Those events that we're looking at, the supernova explosions, they're all gone. They're not happening now. So we need to see both sides of it. We want to play the old videos, and we need to know what's happening now. So when we have a telephone, we you and I are talking on with electromagnetic waves going back and forth. That's fine, but we have to also connect with other galaxies at some point. So I'm just being kind of bold in my thinking here, and I'm not satisfied with what we have so far.
Dr. Conwell speaks to this idea that we may be going through a new Earthrise moment, referring to the 1968 photo in which humans saw the Earth from space for the first time. And whether or not that's true, we do know that we need a kind of biospheric consciousness, planetary consciousness, to address the great problem of climate change and species loss and pollution. I want to pivot to speaking a little bit more explicitly about the state of climate change, because I know you've spent so much time speaking and writing about this issue. And the April IPCC report states that limiting warming to around 1.5 degrees Celsius requires global greenhouse gas emissions to peak before 2025 at the latest and be reduced by 43% by 2030. Curious, what is your assessment of the state of climate?
Yeah, I just finished writing a report on climate change, which is undergoing peer review. This is the conclusion we've come up with. Things are going to get much, much worse. We're only at 1.1 now, and yet we had this devastating flood in Pakistan this summer. And the outcome of that is still not clear. How many people have really been affected? They think about 33 million people were displaced from their homes. The World Meteorological Organization recently released a report pointing out that there's a 50% chance that we will reach 1.5 degrees Celsius in 5 years. That is really bad news. The other bad news is that almost all the projections we've been making lately has been pretty much linear. We just draw a straight line and say, okay, this is how it's going to happen. The feedback loops are not linear. They're non-linear. It could cascade very fast. If we think that today is pretty bad with all the wild, fires around the world, rain, prolonged drought, so on, what will happen even when we reach 1.5? That could happen in the next 5 years before 2030. That doesn't seem like a very positive. And then the question is, are we going to be able to stop all of this within that short period of time? We don't really have much time. If this year's horrible situations occurred in places like Pakistan and Bangladesh, India, other places, what will it be tomorrow? In the same places, where people living there, where are they going to go? So Zurich Insurance Company recently released a report saying that by the year 2050, there will be 1.5 billion environmental refugees. And I think that's an understatement. You know, the world's population then will be something in the order of 9 billion people. It might be much larger than that, but that's the best guess we have right now. And if you think today we are closing our borders to migrants who are leaving Central America to come to our country, people from Africa moving to Europe, people from the Middle East, like people from Syria, other places we have prolonged drought, moving to other parts of the world. This is just a small sampling of what might happen in the future. We've got to move very fast, very, very fast to bring down this goal of 1.5 degrees Celsius. We cannot afford to wait.
Yeah, I appreciate your message of urgency, and some of those statistics are truly harrowing. We did see the Inflation Reduction Act passed earlier this year, which was arguably the US government's most ambitious action on climate to date.
I was very happy when it happened. I'm telling you, the first time in my life, I felt there was some hope.
Wow.
I really felt there was some hope that we passed that bill.
Wow.
But on the other hand, the picture doesn't look so good either. So I am so happy that we did pass that bill, and hopefully we will introduce electric cars very soon, and the solar and wind turbines will be part of our life in the near future. Best we can do is to lessen the impact that we're going to cause of the earth. The impact is going to come, whether we like it or not.
For those of us listening from different parts of the world, what can we do, like as individuals, collectively, which is so important, as folks like Bill McKibben suggest, we must act together, and politically, like where should our levers of influence be right now?
Well, if you accept my ecosystem model of the biosphere, every little thing we do in our own personal life will make a big difference. I work very closely with church organizations trying to make our churches, congregation green. Our church that I attend right now, I'm a practicing Christian and a practicing Muslim, by the way. So, and my son is married to a Jewish woman, so I follow all three Abrahamic faiths, one way or the other. The thing I was going to say is we are trying to make our communities green, small ways, getting heat pump instead of gas to heat your home, things like that. Every little bit helps. And because, think about the motion of fish or birds in flight. They're all moving in an incredible pattern when they move together. And how does that happen? They discovered that it is when you look at your next door neighbor and see where they're going, you follow them. And then the whole becomes into a pattern. It's the same way I think about how we can change our own lives, live more green. And then your neighbor sees it, and then they follow you and so forth. That makes a big difference. Eventually, the whole is greater than the sum of its parts. And that's how I look at it. Don't worry about, it's wonderful to have something like the Inflation Reduction Act pass, because that gives you hope that something big is going to happen. But getting from there to 2030 with 40 or 50% decline in our output of carbon is going to take a lot of work on each of us to do our part. That's how I look at it. We cannot keep thinking about how big the challenges are before us. It is what we can do in our own small way that will make a big difference ultimately.
Absolutely. And I think that's an antidote to paralysis, this idea that if we live in a nested concentric series of holes in this biosphere, every little action we do makes a difference. Nothing is trivial. So I hope that we're kind of leaving today with that galvanizing message. Every time we compost, we choose to take a train instead of driving, purchase an electric car, or, use solar power, we're making a difference in the fabric of the Earth and the universe itself. And so as we come to a close here, Dr. Ahmed, is there a parting message you'd like to share with the Journey of the Universe community?
Well, I think that the one message I can leave behind is to say that the universe is one large cosmic enterprise, and we're all on some kind of a journey, and I'm not sure where we're going, but it's been pretty interesting. And let's hope that our species will live long enough to be able to enjoy where this journey is taking us. I hope that we are responsible enough that we will try to save our species from extinction. We should also save all the other species on our planet from extinction. Some people believe that we are in the beginning of the sixth mass extinction. If that happens, then human species will not survive it. So we do everything we can to save this Earth from saving all the other species. We should not think about ourselves as being the only species that we need to save. We have to save every other species. Mm-hmm. But then we have to think of ourselves as part of this large physical, biological universe that we live in together. And there are other living systems elsewhere too. And when you think about it that way, then we're all on some kind of journey that I do not know where our destiny is. Hopefully it's going to be better than it is now.
Thank you so much, Dr. Ahmed, for sharing your wisdom with me and with our community, for all of the amazing scientific and advocacy work you've done over the course of decades, from work with atmospheric pollution and the Montreal Protocol to work in contemporary climate advocacy. I'm so inspired by the legacy you're leaving, and I look forward to staying connected and supporting your work however we can from Journey of the Universe. So thank you so much for taking the time to chat.
Thank you so much for this interview. I really appreciate you taking the time to ask these questions. Some of them I've been thinking for a long time, and finally having a chance to share them with you.